Welcome, ladies and gentlemen. The data show is about to begin. My name is Chris Greco, and you're here at the data show. For the next 30 minutes, we'll be talking about different types of data, analyzing that data, and applying it to real world situations. In this case, what we're going to talk about today is a real world application of statistics. Now, we talked about standard normal curves, and we've talked about z-scores, and we've talked about t-scores. We've talked about a lot of different things during this year or so that we've had the data show. Well, I think it's about time that we show you how these things are applied. And I think it's very, very important that we start with something medical, because the medical situation is not going to get any less pervasive. It's not going to get any less um, a part of our lives. It's going to be more and more and more a part of our lives. And because of that, the technology that has to go along with that is something that we have to discern, and we have to sit back and figure out what exactly are we going to be able to do with statistics and probability when it comes to medical aspects. We've already done a lot of that, especially during COVID, in different aspects of statistics and probability having to do with vaccinations and all these different areas. But there is an area that uses very, very specific statistical methods, probability methods, to be able to diagnose. And that is the area and what they call a DEXA scan. And we're going to talk about DEXA scan, exactly what that means. And then we're going to talk about what it has to do with what they call osteoporosis. And what we're going to do is show you the the idea behind osteoporosis and what exactly that means in different aspects of that area. So before we get started, we need to define some things, right? Remember, I told you about in data how important it is to define those, and that's pretty important. So what we're going to do first of all is we're going to talk about um, BMD, and BMD is not some obscene phrase. It actually stands for bone mineral density. Bone mineral density. And what this does is this determines how much bone, basically how much bone we have in that situation, so that we have, when we talk about this, we talk about the how prevalent are we to get fractures analysis and those types of things. And that's where it comes around to being bone mineral density. And that is done with what they call a DEXA scan. And we already talked about, we said, hey, look, that's a DEXA. What is a DEXA scan? That stands for dual X-ray absorptiometry. So that's what DEXA stands for. So that's what that means. And so what I'm going to show you right now is I'm going to show you an actual DEXA scan that was done on someone. I will not reveal that person's name, and I've redacted all personal aspects of this entire record, because I want you to focus on a couple of probability and statistical analysis that's done with this. So this is dual X-ray absorptiometry, DEXA, for bone mineral density, BMD. So this is the technique that was done, right? And it says, interestingly enough, is lumbar spine is excluded due to T-score variance. And we're going to talk about why that was excluded in a little bit. But this is, the bone mineral density, 0.937, T-score, negative 0.7. What does that mean? Don't know. Z-score, we'll talk about that. Z-score, 1.1. What does that mean? Well, we've talked about Z-scores and T-scores, but what exactly does that mean? So that's your left femoral neck. This is your left total hip. and that goes into that area. T-score, negative 1.1, Z-score, 0.6, right femoral neck, negative 0.7, 1.2, right total hip, negative 1.2, 0.4. Then we did this one. It's a T-score of negative 3.5 in your left forearm, right? Left forearm. 10-year probability, it says patient does not meet criteria for FRAX, which is the probability of fracture, right? Due to osteoporosis, right? Impression, osteoporosis based on BMD, bone mineral density. So this is what we're talking about. So basically, they are diagnosing this individual with uh, osteoporosis. So here's what the World Health Organization says about osteoporosis. Normal, T-score at or above negative 1 SD. Well, what's SD? SD stands for standard deviation. Standard deviation. So let's take a look at a at a standard normal distribution. Here's a standard normal distribution. This is called a Z-score here. So what are we talking about? We're talking about 0 here, which is also the mean in the Z-score. This is 1 standard deviation, 2 standard deviations, or 3 standard deviations to the right of the mean. And this is 1 standard deviation, 2 standard deviations, or 3 standard deviations to the left of the mean. Well, what does this mean? What does it signify? It signifies that the probability here, you see how it lowers? You know, you got like a 0.4 up here, but all of a sudden that drops to very near 0 back in this area. That means that the number of people that have negative 3 is very small. Same thing with 3, very small. Then it goes up to where you have an average, which is the mean. The mean and the mode will be basically the same here. You have that little hump, and that's what we talk about when we talk about those areas. So that is what we're talking about when we talk about this T-score and Z-score. Now, T-score is based upon the fact that when we talk about Z-score, we talk about standard, right? A standard normal curve. And this is called a normal curve. So that's when we talk about Z-scores, we talk about a normal curve. Well, there is no such thing as an abnormal curve. You can't say abnormal, but a non-normal curve, non-normality, whenever they talk about that, that's when we talk about T-scores. And T-scores are based on what they call the student's, it talks about the student's t-test. And the student's t-test was done by an individual who was, believe it or not, worked for a beer company and found that not all things are standard. We don't have a standard distribution. We don't have that, a normal distribution. Some things are not normal distribution. Some things don't have a beautiful mean and a median and all that. So what do you do with that? You make a t-score. And that t-score is basically based on non-normal, right, curves or distributions. Normal distributions use z-scores. So what do we have here? Well, you have that t-score at or above negative 1 standard deviations, low bone mass, what they call osteopenia, a t-score between negative 1 and negative 2.5, and then osteoporosis, which is a t-score at or below negative 2.5. Remember, I said that probability is very low. So let's talk about this. So what are we talking about? Is there ever a time when that t-score is at or below negative 1.0? Let's see. Remember, at or below, right? So here we have a t-score of negative 3.5. That's in the left forearm. So this is, I mean, it is below that area that the World Health Organization says is osteoporosis. What about this one? Negative 1.2, right? Slightly low, right total hip. This one's a negative 0.7, so that's okay. This is negative 1.1. Again, lower than basically osteopenia, right? And this is negative 0.7. So left femoral neck is okay. Left total hip, osteopenia. Right femoral neck, okay. Right total hip, osteopenia. And then left forearm, definitely osteoporosis. So that's what we're talking about when we talk about those areas. Remember, because T-score at or above negative 1.0. So, and then they talk about different aspects and what patients should do and all that stuff. But this is an actual application of a statistical method. Well, how good is this? Well, I went to the National Institutes of Health and National Center for Biotechnology Information, and they had, are we underdiagnosing osteoporosis with the DEXA scan? So they sat back and they did an entire area having to do with this DEXA scan and the T scores and the Z scores and what exactly that means, right? And basically what they've done is they saw that in conclusion, the study shows that considering all three BMD T scores is potentially more informative than using the single lowest BMD T score. So what they did was in this one right here, they took the lowest BMD T score, which was this one right here. And from that, they diagnosed osteoporosis. Not from these other ones, because the other ones it did not show osteoporosis. It showed some osteopenia based on the WHO standard, but it did not show osteoporosis. They're basing the entire diagnosis, based on the lowest T score, And it's also one of the lowest Z scores too. So you can see that. So interestingly enough, uh, and when I took a look at this, it says, bone marrow density, and you can read this entire thing. In fact, let me give you the the actual reference here, so that so you can look it up if you want to look it up. But this is it's a really good. I'll tell you, the National Institutes of Health is really good at this type of stuff. I really like what they do. I like their studies. I like the way they look at it. I like that, and especially in this situation here. So what they're saying is, they're saying, look, is if a person, let's say, has a Z score or T score that is above what is recommended for osteoporosis, then is that person does that person have osteoporosis still, even though they were very close, but they weren't in that range that would deem it to be osteoporosis. So that, I mean, it's very interesting. They talk about the different aspects and what it talks about T score threshold and how that's, it says, these individuals noted that the BMT score threshold value of negative 2.5 identifies approximately 30% of postmenopausal women as having osteoporosis using BMD measurements. And this 30% is approximately equivalent to the lifetime fracture risk at these sites in postmenopausal women. This is why the threshold of T-score of negative 2.5 was used to define osteoporosis. Prior report noted that this definition makes osteoporosis population-based statistics-based, or population-based statistics-based rather than BMD-based. But that's what T scores and Z scores are based upon. They're based upon a population, right? They're based upon or a sample as much as possible. But if this is population based, which is a population of everyone that has a possibility of getting osteoporosis, they're saying, hey, look, there's an issue here. And they go through different tables, different aspects on this. It's really, I mean, it really is, it's a good study. And then it talks about the different statistical theory, which you need to read, because this is what, they took to understand exactly what they were talking about. And then he took 1,000 postmenopausal white women with DEXA studies evaluating the BMD on the L1 to L4 lumbar spine. Now we sat back and we said, wait a minute, Chris, hold on. when we talked about the lumbar spine, it says right here, lumbar spine is excluded due to T-score variance. So comparison is none. So the lumbar spine, the L, whenever you see like L1, L2, L3, that's the lumbar spine, right? And it's interesting because I think, if I'm not mistaken, the L1, L2, L3, all that, the L15 or L14 or whatever that is, lumbar spine is down towards the lower part of your back, right? C1, C2 is cervical, so it's up in this area here. So that's where, the T-score variance is either too high or it's not enough to be able to show a difference. And you have to be able to show a difference. You have to be able to, that's what hypothesis is all about. Whenever we talked about hypothesis, and this is important, and we need to hit this up real quick, is a hypothesis, right? So what you have is, when you have a hypothesis, you have what they call a null hypothesis and alternate hypothesis. Now, a null hypothesis means that it means that both samples are equal, right? So that's a null hypothesis. Both samples are equal normally. That's a null hypothesis. Alternate hypothesis, or alternative hypothesis, however you want to say it, I've seen it used both ways, means that both samples are different, and some in different ways. It could be one sample is greater, one sample is less. It goes like that. That shows what they call an effect, EFFECT, effect. So that's what, when we talk about effect, it means that there is actually a difference. That difference is measured by what they call a p-value. The lower the p-value, the more that you're going to reject that null hypothesis, which means that both areas are the same. You want that difference in this situation. Well, if we go back up here, you're going to see that the p-values here are really low. Here's a p of, the p-value is 0.001, and hip fractures p-value is 2.2 times 10 to the negative sixth. Both of these are less than 0.05, which is a normal, the normal, what they call alpha measurement. As long as it's lower than 0.05, then you can say you can reject that null hypothesis, and that means that there is a difference between two samples, two areas, and that's what they want. They want that difference. So that's really interesting from the standpoint of how that all works. And that's why it is very, very important to understand how this all works, what the standard deviation is, what the mean is, but it's not like you have to memorize all this stuff. The standard deviation, and this is where we talk about these areas. The standard deviation is going to be the difference between the values and the mean. The difference between the values and the mean. That's how you come up with a standard deviation. So that's 1, 2, or 3 standard deviations is just one standard deviation is the standard deviation between the mean and the value. The mean and the value. And then there's a formulary that goes along with that, but basically that's what we're talking about. And it's squared, and then it's over the number of events, and that that's how you get that standard deviation. And then it's then you have this is a standard normal distribution. In a normal distribution, not being standard, you'd have mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation. And that's a normal, but this is just 0. 0 is, in a standard normal deviation, 0 is the mean, and 1 is the standard deviation. So if you have mean plus 1 standard deviation, you have 0 plus 1. Mean plus 2 standard deviations, you have 0 plus 2. And this all gets into statistics, and something that probably you've had nightmares about since your undergrad days. But that is what we're talking about, and this is a statistical approach when we talk about that. Now, there are some other ones. This is a Medical News Today, and it talks about DEXA bone scans, and it centers on Z scores rather than T scores. So here's you have the z-score. Now we'll go back here. Remember, there were z-scores on this thing too, right? So here's a z-score of 1.1, left femoral neck, z-score of 1.1. The z-score is based again on normal distribution. So it looks like the standard normal curve. That's normal distribution. So here's your 1.1. Well, is that good, bad, or whatever? So let's take a look. So 1.1 is it 1.1. So 1.1 says bone density is higher than in others of the same age, sex, and body size. You're comparing people to that. Now, I'm going to tell you, interestingly enough, that z-scores, the t-scores are based on a standard age, whatever that may be, 30 years old, I think it is. The z-score is based on that specific age. That specific age. Now, the age of this individual is more than 30 years old. So that's why the t-score may not adapt well to that specific individual, but the z-score maybe more so. So there's 1.1. So 1.1 is good. That's a good thing. Higher than others, same bone density is higher. So there's your z-score. It's good. Now let's go back down here. Here's a z-score of 0.06. Now as you get to 0, you're going to have more and more towards the average, right? So here's 1.2 right femoral neck. That's good. 0.4, good. Negative 1.8 left forearm. So let's take a look at negative 1.8 and see what it says. So negative 1.8 is still, doctors consider scores higher than this to be normal. So here's a z-score. Here's a negative 1. Here's a negative 2. Wait a minute. Negative 1.8, when we talk about this, negative 1.8 means that even though this individual has a negative 3.5 t-score, which shows osteoporosis, the z-score, which compares their bone density against others of their age and of their sex, and whatever else, is negative 1.8, which according to the WHO means that it's actually okay. It's actually okay. So I mean, so that's what happens here. It's like, whoa, what's going on there? Dual energy. Oh, so it says, so I said dual X-ray, but this is dual energy X-ray absorptiometry. So DEXA is dual energy X-ray absorptiometry. I hope I'm pronouncing that correctly. I'm sorry. Scan. So that's DEXA. That is, I want to make sure that you understand that's what we're talking about. Dual energy X-ray absorptiometry scan, DEXA scan. Okay, so that's and this is where you have to do some work on this. You have to take a look at this. So I went to another place, Cleveland Clinic, which actually is very good. And then they talk about different aspects, dual energy X-ray scans, and vertebral fracture assessment. So all these things, and it talks about different aspects: who performs it, what does it work, how do I prepare, what can I expect, who's not a candidate, what do the results mean? Here we go. A t-score greater than -1 is healthy. Between -1 and -2.5, slightly decreased bone density, osteopenia, and below -2.5 is osteoporosis, which is again the lowest score. You get the lowest score, which in this case was -3.5 for this specific patient, you have osteoporosis. So that's what we're talking about. Now, I'd like to know if I don't want anything more. I don't want to know anything more about this patient. It's redacted and whatever else. But I think it's interesting to sit there and say, okay, you have osteoporosis based on one score, lowest score, and in one area, which in this case was the forearm, and that designates individuals with osteoporosis. So is that the right way to do that? Well, according to the National Institutes of Health, it's not just good, but and in fact, are we underdiagnosing osteoporosis because we're only taking one scan? or one, we're only taking the lowest score? Are we underdiagnosing it, which is interesting? And they do that through a series of correlations and everything else that has to go along with that. So this is something. This is an area that is just very interesting to me, because you sit back and you go through this stuff, and a lot of people say, I just don't have, you know, you know, I don't know where this is used. I don't understand where this could be used in any type of situation whatsoever. Well, here's a situation where it's used. I mean, literally, they use Z-score and T-score for this whole thing. They use it. So, I mean, it's not like this is something that's, oh, we're going to use another term. They used a basic statistical process and method that you were all taught if you took any undergraduate statistical class whatsoever, or quantitative analysis or anything else. You learned this. You learned it. So if you learned it, then it's the same stuff they use. This is what they use. So I think when we talk about this, I mean, sometimes I go into theory, go into those aspects, but basically this is stuff that's undergrad statistics. And the more that you learn about this and the more that you understand it, the more that you'll be able to understand how probability and statistics is used in our daily lives. And yes, okay, many of us are not going to sit there and say we have osteoporosis, or we're going to go into, but there are friends of yours, there are relatives, there are people that go and get this test. They go and get this test. And it's very important that you understand how this test works. Not so much you can medically advise them, but you can understand it, so you may be able to explain it a little bit better to them, or at least ask the doctor some good, solid questions that everyone should be able to understand. And that does it for the data show for this for this Thursday. And I think it's very important to understand that, along with checking the data, which I always tell you to do, is to check the theory, check the method, check to see if the theory really is something that is reliable and it's repeatable. And I think that's very, very important when it comes to that. So in the meantime, have a great rest of the week. And remember, this is the Data Show. My name is Chris Greco, and you've just finished 30 minutes of looking at data in an application mode of things that have to do with data and your life.